My dear students, in continuation of mark scoring videos for senior intermediate, today we are going to discuss an important question of 14th chapter called Nuclei. This is the most important question. In all papers, you will find this question. Let me read the question. And this essay type question, along with this essay type question, there will be one small problem. I am writing here two expected problems, right? Right. The question reads, explain the principle and working of a nuclear reactor. So this question is related to a nuclear reactor. We will discuss what is a nuclear reactor. Explain the principle and working of a nuclear reactor with the help of a labeled diagram. So labeled diagram is a diagram in which we write the names of the parts. Right. This is the main question. There is a probability of getting a 2 marks or 1 mark problem. These are the two questions we will be discussing in this video. Right. This is very, very important question. In this chapter number 14, that is nuclei, I am going to discuss only this question. I am not going to discuss the other question because this question is very, very important. Is this clear? Right. Now, what is a nuclear reactor? So, this is the schematic diagram of a nuclear reactor. So, nuclear reactor is the source of nuclear energy. So, what is nuclear energy? We will be discussing. So, by using a nuclear reactor, we produce electricity. So, this is the nuclear reactor. So, what are the parts of nuclear reactor that we will be discussing? And with this, we are able to rotate a turbine. Because of that, electricity is generated. And this electricity, you can produce large amount of electricity. I will give a rough idea. In US, that is in America, 90% of electricity is, I think, nuclear energy based electricity. In India, very less. So 2% of electricity in India is from nuclear reactors. So nuclear reactors, nowadays, the latest government is planning to build many nuclear reactors. There are pros and cons related to nuclear reactors. And if a nuclear reactor goes out of control, then that will become a nuclear bomb. That is the main danger of this energy resource. So in Chernobyl is situated in Ukraine. In recent newspapers, we read something is happening in Chernobyl nuclear reactor. For us, we have Kudankulam nuclear reactor, Kalpakam nuclear reactor. We have many reactors in our country also. So, this is about the nuclear reactor. So, I will go in detail. Right. So, before I go into nuclear reactor, what is a nuclear reactor? Nuclear reactor is a device. This is the answer for 1 mark question. In the beginning, you have to write the definition. It is a device in which a controlled nuclear fission reaction takes place. If you write this line, you will be getting 1 mark. In which a nuclear fission reaction takes place. So, fission means what? Fission means there is a bigger nucleus. When it is bombarded with a neutron, it splits up into 2 or 3 fragments, into 2 or 3 pieces. Not only it undergoes fission, or not only it undergoes the splitting up of the nucleus, it also gives enormous amount of energy. Huge amount of energy is released. So that is the basic definition of nuclear fission. So in the exam, for the purpose of this question, for you no need to write any definitions related to nuclear fission reaction. But I am writing here. So what is nuclear fission? Nuclear fission is a reaction related to nuclei. Nucleus. You know nucleus. Once again I am going into the fundamentals. This is an atom. In the center of the atom you have nucleus. Nucleus consists neutrons plus protons around which electrons are revolving. So nucleus is bound in a small space of the order of 10 to the power of minus 15 meter. This is also called 1 Fermi. If you are able to touch the nucleus to split it, you will get a huge amount of energy, right? So I take a bigger nucleus. Only bigger nucleus can undergo fission reaction, not the smaller nucleus, because this bigger nucleus is having less stability. Less stability means it is already having some disturbances inside. So when I bombard it with a neutron, this neutron is called as thermal neutron. What do you mean by thermal neutron? Thermal neutron is not related to the heat or the temperature. Thermal neutron is a neutron whose kinetic energy is very, very less. That means its velocity is very less. The kinetic energy of the order of 0.025 electron volt. Very, very, very less. So in order to start a nuclear fission reaction, the triggering part is you have to bombard the nucleus with a neutron, and that neutron is called as thermal neutron, whose energy is very, very less, whose velocity is very, very less. That can only start the fission reaction. Is this clear? Right. These are the fundamentals you are supposed to know. Right. Right. What happens in a nuclear fission reaction? Let us see. So when a neutron is bombarded with uranium, uranium is a unstable nucleus, 92 uranium-235. When I bombard it with a thermal neutron, what happens? It splits up into two nuclei. One is barium, the other one is krypton. So it is 56, 141 atomic numbers and weights. This is 36, 92. Not only this, it also gives 3 neutrons plus around 200 million electron volts of energy. So this is thermal neutron. When it bombards with 92 uranium-235, it gives out barium nucleus plus krypton nucleus, and these 3 are 3 neutrons. So what happens? These 3 neutrons once again bombard with 3 more uranium nuclei, giving out 9 neutrons. Those 9 neutrons once again bombard with 9 more uranium nuclei. In this way, this process goes on. And that process is called chain reaction. So this is the neutron bombarding. So it is splitting up into 2 nuclei. This is nuclear fission reaction. Right. What is chain reaction? So this is chain reaction. You can see. So one neutron gives 2 or 3 neutrons. On an average, it gives 2.5 neutrons. So in this example, it is showing 2 neutrons. One neutron giving out 2 neutrons. These 2 neutrons are bombarding with 2 more nuclei. Then it gives 2 here and these 2 here. In this way, this continues. I mean, this what do you call this reaction goes on continuously. So I will show you. So this is uranium. It's bombarded with neutron. This is neutron. Then it gives barium and krypton. It also gives, let us say, 3 neutrons. I am giving out 3 neutrons. If these 3 neutrons are also thermal neutrons, suppose they are not thermal neutrons, if their speeds are very, very less, they once again bombard with 3 more uranium nuclei, uranium. They once again they give 3 neutrons. Here also 3 neutrons. These 3 neutrons, they will collide with 1 more uranium, here one more uranium, here one more uranium. So once again you will get 3, 3, 3. In this way, this reaction continues in nanoseconds. Huge amount of energy is emitted. So this is the basic principle of an atom bomb. In this, the reaction is uncontrolled. In this, the reaction is uncontrolled. That is the reason why it is called as chain reaction. It continuously goes on. In the beginning, I used 1 neutron. It is giving 3 neutrons. In the next stage, 3 square neutrons. In the next stage, 3 cube, 3 to the power of 4, and so on. Infinite number of neutrons are emitted. So, infinite fission reactions are taking place. So, huge amount of energy is released. So, this was done by US in bombarding Hiroshima and Nagasaki in the Second World War, I think. Is this clear? So, this is called chain reaction. A scientist called Enrico Fermi, a great scientist called Enrico Fermi, devised a device called nuclear reactor. Why he devised a nuclear reactor? So, this uncontrolled chain reaction can create a holocaust. That means it can kill many people. It is not at all useful for humankind. But he thought that the same energy releasing reaction, why can't it be used for the benefit of human being or for the benefit of mankind? So, he devised a nuclear reactor. So, suppose in this nuclear reaction, I want to stop the reaction here only. I want to curtail this reaction, I want to stop this reaction, I want to cease the reaction, and I want to utilize the energy released here only. Further reaction is stopped. How to stop? That he thought. So, if you are able to control the reaction at some point, you can utilize the energy for the purpose of ourselves. So, if you want, you can stop it here. If you want, you can stop it here. You are satisfied with the energy released, then you will stop this. This is just like, take the example of our household stove burner. Once the food is cooked, what we do? We switch it off. Whenever you want, once again you switch it on and you cook the food. The gas is not continuously burning. You are able to stop it. You have a controller in your hands. Are you following? Right. So, that is nuclear reactor. So, this is the nuclear reactor. You have to draw this diagram. Remember, there is no particular diagram for nuclear reactor. This is just like the diagram of amoeba. Whatever the shape you want, you can draw. Is this clear? Actually, in reality, a nuclear reactor is spread over acres of land. It's a very complex structure. You cannot understand. This is the simplified structure. Is this clear? A nuclear reactor mainly consists 5 things. Number one is fuel. This is number 1. Number 1 is fuel. What is fuel? We will discuss. Number 2 is control rods. Number 3, moderator. Number 4, coolant. Number 5, concrete wall or what do you call radiation shield. So, these are the 5 things. If you write 5 lines under each headline or each heading, you will be given 8 marks. Is this clear? Right. So, I will try to draw a diagram. So, in this nuclear reactor, there will be a main part of the reactor called core. This core consists fuel, they are fuel rods. Number 2, controlling rods. Number 3, moderator. Number 4, coolant. This is the main part. So core is the heart of the nuclear reactor. Is this clear? Right. Now, so what do you mean by fuel rods? Fissionable material like 92 uranium-235. The one which can undergo fission reaction is called fissionable material. That fissionable material is the fuel. In your household stove, butane is the fuel. For your car, petrol is the fuel. For somebody's car, diesel is the fuel. For somebody's household cooking, wood is the fuel. In olden days, there used to be kerosene oil. Nowadays, we are not finding that. So, fuel can be uranium, it can be plutonium, it can be thorium. So, these are taken in the form of pellets. Pellets are just like coin-shaped pieces. So, I took many pellets. And these pellets are filled in aluminum cylinders. There are thousands of such fuel rods. So, a fuel rod is nothing but an aluminum cylinder in which I will put these pellets of uranium or thorium or plutonium or something else. Is this clear? Right. This is one. Right. So, this is about fuel. Now, what about control rods? So, which is responsible for nuclear reaction? Neutrons are responsible. If I introduce something into the nuclear reactor, as soon as I introduce this rod, if it is able to absorb all the neutrons, if it eats all the neutrons, further reaction is stopped. The reaction will cease here only. The duty of the control rods is to absorb neutrons. This is one. To stop the neutrons. To stop the nuclear fission reaction. As soon as I stop the reaction, everything will be closed down. No power will be generated. Now I want to restart the nuclear reactor. Just I have to pull the this controlling rods out of the nuclear reactor. If I push them inside, the reaction will cease. As soon as I remove when I pull them out, the reaction will continue. Is this clear? So, this is the usage of control rods. This is the purpose of the control rods or controlling rods. Next. Just now we discussed in the reaction, so this is one uranium, when bombarded with one neutron, I may get 2 or 3 neutrons. On an average, we get 2.5 neutrons. So, in some cases, we will get 2, in some cases 3, the average is 2.5. These neutrons are not thermal neutrons. If they are not thermal neutrons, the further reaction will not continue. If I want to continuously produce the electricity, if I want to produce the energy continuously, then I have to convert these fast moving neutrons. The fast moving neutrons must be converted into thermal neutrons. So, I introduce a material called moderator. What does it do? Moderator can be heavy water or graphite. Moderator can be heavy water or graphite. So, what does it do? A fast moving neutron collides with the moderator, it loses its energy, it becomes a thermal neutron. Are you following? A fast moving neutron collides with the atoms of the moderator, they lose some energy, they come out, after dissipation of energy, they come out as thermal neutrons. So, controlling rods to stop the reaction, moderators to continue the reaction. To make it available, the required number of thermal neutrons, then only this reaction will sustain, will continue. So there are two things. In a nuclear reactor, you can stop the reaction, you can start the reaction, and you should see that the reaction should not go beyond our control. It should not become a nuclear bomb. So for that purpose, you require controlling rods, moderators. You also require heat absorbers. What do you mean by heat absorbers? So nuclear reactor is nothing but a very big room. In this reaction is going on. Huge amount of heat is produced. So you have to continuously remove the heat from this room. Otherwise, this will melt down and this will blow up. This will explode. So what I do, I send the cool water. Then this will become steam or hot water. So this cold water carries the total heat and takes it out. So what is the duty of coolant? The duty of the coolant is to remove the heat from the core of the nuclear reactor. I utilize this heat to run the turbine. Is this clear? Right. So this is the fourth part. So till now I discussed control rods or controlling rods. Number 2, or first one is fuel. Second one is controlling rods. Third one is moderator. So examples for controlling rods are, remember, boron and cadmium. Boron and cadmium. Moderator, heavy water and graphite. Coolant, water or liquefied sodium. Is this clear? In some cases, we also use heavy water. Right. So these are all the necessary parts of the nuclear reactor. If one is missing, then it will become a bomb. Is this clear? Right. Next one. In the nuclear reactions, some nuclear radiation is emitted, like alpha, beta, gamma radiation. If they fall on us, we will get many diseases like cancer or permanent disability. Is this clear? They are very, very, very dangerous. So what they do, around the nuclear reactor, they construct a thick wall, a concrete wall, whose thickness is around 10 meters. 10 meter means the length of this room. Is this clear? That much thickness. They also have some lead sheets in it. So this lead and this concrete, they stop this outgoing radiation, like gamma radiation. So these are very, very important. So fifth one is shielding. You are shielded from this dangerous, hazardous radiation. Is this clear? Right. So you have to write these 5 parts and you have to draw the diagram. So this is the diagram. So very simple diagram. I will try to draw for you. Right. So first you draw one box. In this you put controlling rods. 1, 2, 3. So they can be moved up and down. If you want, you can take them out. If you want, you can push them inside. This is one. Next one is fuel. These are fuel rods. And next one is moderators. Wherever you want, you can put. There is no particular diagram. This is just like just now I told you, drawing the shape of amoeba. Right. So what are you sending? You are sending cold water into this. Then hot water comes out. This hot water, this is the hot water. So this hot water is going to cool the cold water in heat exchanger. So in heat exchanger, once again cold water is entering. So these tubes are heating this cold water and they give out steam. And this steam rotates the turbine and this turbine or generator produces electricity. That's all. So around this you draw one more box. And this box indicates the shielding. Is this clear? This is the wall of thickness 10 meter. That's all. So labeled diagram means here only you write this is controlling rod. Let us say this is fuel rod and this is moderator. This is water is entering and water is leaving. So write coolant. No need to draw even this part of the diagram also. This is called heat exchanger. No need to draw that part. This part is enough. Here you draw, this is shielding, right shielding. That's it. So wall is nothing but shielding. So this is shown in the first slide, animated slide. This is. So these are the control rods. They can be pushed inside or it can be taken outside. So this is cold water is running, right? So this cold water is going through the heat exchanger. Here this cold water is becoming steam. This steam is rotating the turbine. This in turn rotates the generator. Leave this part. Once again this steam is becoming water. That's what he is showing. No need to show all this. This part you can remove. No need. So no need to draw this diagram also. So electricity is produced and we are supplying that to cities. That's what this diagram. Is this clear? So what is very, very important? The very, very important part is no need to define fission reaction. No need to write the equation of 92 uranium-235. No need to write about chain reaction, controlled, uncontrolled. This diagram is also not necessary. Only to know, for knowing purpose only. So this diagram is very, very important. This diagram is taken from the old textbook. In our textbook, the diagram is so simple. That is very, very small in size compared to this. Even if you draw that also, you will be given 8 marks. But the thing is, you have to write about fuel. This is one. You have to write about controlling rods. Next, you have to write about moderator in 1 line or 2 lines. Number 4, coolant. Number 5, shielding. That's all. So for each point, you will be given around 1.5 mark. For the diagram, 1 mark. For the definition of nuclear reactor, 1 mark. In few cases, they will be asking questions or problems. We are considering 2 problems of our textbook for this exam purpose. The question reads, if 1 microgram of 92 uranium-235 is completely destroyed in an atom bomb. Just now I told you, in atom bomb we use uranium, a fissionable material. So that when it explodes, 1 gram means there are thousands, crores of atoms or nuclei. Once it explodes, how much energy will be released? This is the question. So how much mass? Mass is 1 microgram. Microgram means 10 to the power of minus 6 grams. So convert this into kgs. 10 to the power of minus 6. 1 gram is 10 to the power of minus 3. Total 10 to the power of minus 9 kg. So here you have to use Einstein's mass energy equivalence. Equation of Einstein's mass energy equivalence. So it says E is equal to mc square. Energy released is equal to mass times square of the speed of the light. What is the value of C? C is 3 into 10 to the power of 8 meter per second. We substitute this here. So E is equal to how much energy is released? M is how much? 10 to the power of minus 9. C is how much? 3 into 10 to the power of 8 whole square. So this is 10 to the power of minus 9. This is 9 into 10 to the power of 16. Is this clear? So you will get E is equal to 9 into 10 to the power of 7 joules. If you write this much, you will be given 1 or 2 marks. In the same way, one more question is there. Calculate the energy equivalent to 1 gram of substance. Here microgram, here 1 gram. So answer is E is equal to mc square. M is equal to how much? 1 gram. 1 gram means you have to convert it into SI units, 10 to the power of minus 3 kg. So 10 to the power of minus 3 into 9 into 10 to the power of 16. So this will become 9 into 10 to the power of 13 joules. That's all. Is this clear? So if you write this much, so drawing the diagram is very, very important, and write about the components of the nuclear reactor, you will be getting 8 marks. Thank you. In another video, we will be discussing one more question. Thank you.